Hello dear learners, welcome back to my channel. In today's video, we are going to talk about a very important concept related to Spring, and that is inversion of control. If you have been following my channel, you know that in our previous video, we spoke about the Spring architecture, wherein we were talking about the various features of Spring, wherein we spoke about core container, and we spoke about AOP, instrumentation, messaging, data access integration, web, testing modules, etc. Now, inversion of control is also a very important concept for one who wants to learn Spring. Important because that lays the whole foundation of Spring. That is where the whole layout of Spring is, or that is how the whole Spring architecture has been laid down. So again, it's a very important concept for us to learn. Okay. Now, inversion of control, if I have to explain very simply, let me take this example for you. Let's say I have a car. And cars usually have tires, right? So let's say I want an MRF tire for my cars. Okay. If I have to implement this programmatically in a code wherein I want to create a car class and have MRF tires with it, I will have to do something like this. I will have to create a class car, and I'll have to create the objects of MRF tires, okay, which will allow me to have a car, allow my car to have MRF tires. Correct? So here basically I am creating a dependency between the car class and the MRF tires class, right? So that's one thing. Now let's say in future, if I want to change my tires from MRF tires to, let's say, CEAT tires. Now for implementing this again programmatically, what I will have to do is I will have to go to the car class and change the object of MRF tires to CEAT tires. Now you must have observed that I am trying to make a change in the code. Now, if you talk about object-oriented programming, this is not a very recommended way of implementing code. Object-oriented programming always follows something which is called as an open-closed principle, right? What exactly is this open-closed principle? It says open to extension but closed to modification. I'll repeat. Open-closed principle is open to extension but closed to modification. Now, what it means here is that any class that you create should be open to extension. That is, if there is any change, it can be extended in that particular class. But you should always avoid modification in a particular class, or it should be closed to modification. That is what the open-closed principle is. Now, because of a design that we have here, that a car class has a dependency on the tires class, what we are doing here is we are tightly coupling the car class and the tire class here. So every time I want to change the tire of this particular class to a different type of tire, I will have to every time come to the car class and change the code, right? So this is basically tight coupling. Again, something which is not recommended in the object-oriented way of programming. We always talk about loose coupling and high cohesion, right? So again, something which is not recommended. This is what primarily Spring architecture catered to and was handled beautifully using the concept of inversion of control. So now, how does inversion of control help us in this? So let's again assume I have a car. Okay. Now, rather than the car doing the every job here, like you can see here, the car class is creating the object of the MRF tire class. We have something into picture called as a container. Okay, a container, or you can say a framework which will do this job for us. So what the car class has to do? The car class has to just declare that I need a tire. The tire could be any tire that you want, right? Today, let's say if you want an MRF tire, you can have MRF tire. Tomorrow, you want CEAT tires, you can have CEAT tires. How will this be enabled? With the help of this container. So my car class will just declare that I want a tire, right? And it will be this particular framework which will do what? It will generate the object of the tire class and give me. Now something like this can be easily implemented by the concept of interfaces and classes. If you are aware of that, you would understand that tire here is basically an interface, whereas MRF tires is a class here. So that's one of the ways of implementing inversion of control, right? Today I'm using MRF tires, I can have the object of MRF tires. Tomorrow, if I want to change this to, let's say, CEAT tires, I can easily do that without, you can see here, changing the car class. There's no change in the car class. It's the container who's doing the job for me and getting me the object that I wanted, right? This is what Spring Framework enables us to easily implement, the whole concept that we are talking about of object-oriented programming, as I have said in my previous videos also, that Spring rightly implements the object-oriented concepts, the concepts like loose coupling, high cohesion, and the open close principle. So all basic principles that were object oriented principles are rightly implemented using the Spring framework. So that is what it does, and allows us something like this that we are doing here, that there is a container which is allowing us to inject this particular dependency in the car class, okay, externally. Such a concept is called as dependency injection. Okay, so that is what dependency injection is, wherein we are externally injecting a dependency for a particular thing, right? So in short, if I have to say, that is what dependency injection is. That is, you are injecting a dependency externally rather than creating it inside the class itself, so that in future, if there is any change in this particular dependency, the actual class does not have to change. Okay, again, this is very easily, this whole dependency injection concept is very easily managed through XML files or through annotations, so that it is easy to change it here as well. So we are not saying ki, you create a class and create an object there and it becomes difficult to implement this. It becomes easier, much more easier with Spring and with the concept of dependency injection or inversion of control to implement the whole concept. Okay. In our future video, we will be talking about what exactly is dependency injection in detail. We will also be talking about the various ways in which dependency injection can be implemented, what are the various ways of doing it, and post that we will be talking about the Spring Maven dependency. That's again a very important concept, because theoretically we learn a lot of things, but when it actually comes to implementation, that is what is most important, that whatever you've learned as a concept, how to implement that in the code. So stay tuned. That is it for today's video. If you feel like commenting on my videos or anything that you would like to mention about my videos, please mention that in the comment section. If you like my content, please like my videos, share it with your friends, family, and thank you for watching my video. Bye bye. Have a nice day.